Okay, I mean, so far we have talked about building technologies in so many different ways, roofing and walling, and we also talked about testing appropriate technologies and so on and so forth. Now there's a new dimension of the buildings, the damages. Buildings do get damaged. So how do you repair them? How do you restore them back to their original state? Now, repairing damaged buildings, you have basically two types of buildings we have talked about. The frame buildings, typically reinforced concrete frames, which are the most common in India, and the box type masonry buildings. Now, when a reinforced concrete frame building is damaged, it's generally it's difficult to repair and restore it back to the original state. The kind of procedures and equipment which are involved are pretty sophisticated, and it requires rigorous engineering input. On the other hand, when you have a box type masonry structure, it's relatively easy to bring it back to the almost near original state, which was there before the damage occurred. Procedures and equipment are simple. Sometimes very, very basic equipments are used. Nothing sophisticated, and most of it is all based on thumb rules, like what we have said thus far. So, why restore a damaged masonry building? Primarily because it's cheaper to do that than to demolish and rebuild a building. So basically what I'm going to talk about today, is the box type construction with load bearing masonry. Masonry can be of stone, brick, concrete block, and the mortar can be mud mortar, cement mortar. The roof can be pitch roof of different types, or it can be flat roof, reinforced concrete or earth and timber. So just two visuals of what kind of buildings we'll talk about. Now, the principal agents of damage, number one is poor quality, as we have talked again and again. Lack of maintenance, I think, which is a very common situation across our country. Age, older the building, more problems there could be. And impact of potentially destructive natural phenomena, like earthquake, cyclone, floods. Now, we have the seismic zonation map, which shows in different parts of the country what kind of risks there are and what kind of, higher the risk, bigger are the earthquakes likely in a foreseeable future. And obviously, greater is the chance of having damage. Now, just few visuals of different typologies. Here is a building in Jabalpur, a brick masonry building back in 1997 earthquake, and a stone masonry building in Kutch, and a brick masonry building again in Kutch, and stone masonry building in Kashmir. Variety of masonry buildings after different earthquakes. Also, the other hazard is cyclone, the high wind speed. So from the same site, you get the wind speed map, which tells you what kind of wind speed can be expected and what kind of risks there are. Then, here are some visuals of cyclone damage. Typically, roof getting blown off, very, very common in the buildings which are light or moderately heavy roofs, where the roofs get blown off. Also, very common are the compound walls getting blown off because they are just freestanding, very vulnerable. And you can have sometimes the building walls collapsing for a variety of reasons. Then comes the floods. Also for the floods, you have the same kind of map. But I think today, especially with the kind of climate change, the kind of precipitation we are seeing and the flooding we are seeing, that particular map is really of no use. It shows very few areas, which are flood prone. But I would really go by that. Again, these are some of the floods back in 1996. We had seen floods in Punjab, Satluj River overflowing, and then in Gujarat, Saurashtra, 2005 earthquakes, tsunami in 2008, Indonesia tsunami in Banda Aceh, and floods in Kosi. And actually, even right now, I think Kosi is flooded, and really wonder what, I mean, they are expecting big floods because the water being released from Nepal. So, variety of reasons, but typically in floods, either you have direct impact on the walls. The walls maybe may not be strong enough. The walls break, and a lot of times, or more often, you have foundation getting scarred, and then the whole building collapsing. So that's the kind of damage you have. Now, going back to the question, why repair and restore the buildings which are still standing, damaged, partly damaged, heavily damaged. Now, reconstruction means demolition. If the building is still standing even partly, it has to be demolished. The debris has to be removed, and then you reconstruct. Each stage costs money. Okay, so that's why it's very expensive. Repair and restoration basically means you are dealing with only part of the building. You are not dealing with the whole building. You are dealing only with portions, and that's why it's cheaper and faster than reconstruction. Then you are bringing the structure layout. Some walls are collapsed, so you're bringing the layout and the strength to the pre-damage or pre-disaster stage, and you make it functional so that it can be again occupied and start using it as house or whatever. Now, we typically build a house and we convert it into home. That's a big process involved. Okay, you get a box, and then you do so many things gradually to make it a home. So, you have all kinds of conveniences and decoration and all kinds of things. So when you're working with an existing building, it's only part of the conveniences have to be restored, and because they may be damaged. If you're reconstructing, it means everything has to be done from scratch, which means enormous cost and a lot of time. All right. Then bringing the vulnerability status close to the pre-disaster, because earlier possibly the building was more vulnerable, and you have an opportunity to reduce the vulnerability. So you also inspect the building from that viewpoint when you're working on the repairing and restoration. Now IS 13935 has this section 4, which focuses on these repairs and restoration. Now repairs, they are structural and non-structural both, the damage. So non-structural repairs, it says that it has to be carried out before the structural ones, but it all depends what kind of damage you have, because, plaster, plane, flooring, roofing, a lot of small things, electric power lines, water lines, and then the structural damage, basically, that's what the main concern that we are talking about right now is, bringing back to the pre-disaster or pre-damage situation. And the first thing you need to do is you have to assess the damage. And I'll talk about that, what I mean by assessment. And next, once it's assessed, then we carry out the repair and restoration using appropriate methods, which could be, some of the stuff will be so badly damaged that you may have to remove part of the damaged portion and rebuild it. Okay, some of the damage can be just repaired right in place, by grouting and putting some splices across and things like that. And you may have some reinforced concrete or timber elements, which would require different kind of treatment to restore it back. And in this work we use quite extensively the ferrocement elements using the weld wire mesh and rich cement mortar. So, okay, now you have individual damage. Damage category has to be assigned. So, you may have right here, you may have a lot of different damage. So you have to identify each damage and you have to assign the category. Alright, now there is a way to do it. The other is the whole building damage. Okay, there are two different things. You have a lot of little cracks and variety of things, which each damage has to be categorized, which is G1 to G5. and then you have the whole building damage level. Okay, I mean all that individual damage adds up to decide to what level the building is damaged. Okay, so that is called assigning the grade of damage, grade 1 to grade 5. Alright, now individual damage categorization. Grade 1, this is what you call a hairline crack, and more often than not it's just in plaster. Even without any kind of disaster, you can have lots and lots of cracks in the plaster for a variety of reasons. Okay, so it's basically non-structural crack. But you can also have cracks in masonry. Okay, it is not just plaster cracks. They can also be in masonry, but they are really hairline. You cannot measure their thickness. Then you have G2 cracks, which are basically hairline up to 5 millimeter width. These are structural cracks. They are two-dimensional cracks. So they basically have a length and the width. So when you measure the quantity of damage, you have to measure the length and the width of the damage. Then you have G3, which are cracks which are actually 6 millimeter to 10 millimeter. Okay, they are three-dimensional. They have width, their length, and their depth. And typically, those cracks are through the thickness of the walls. G4 damage, where the portion of the wall, portion of the structure is in what's called the state of impending collapse, which means it's in such a state that a little bit of shaking will result into collapse of that portion, or it may have already collapsed. Correct? State of impending collapse, or small parts may have already collapsed. So that is G4 damage. And G5 is more than 50% structure is in state of impending collapse or total collapse. Okay, so this is a standard way of categorizing the individual damage. And what we have seen, after a disaster, when somebody goes to assess the damage, because that is a major exercise that requires to be done after every disaster. There are people who go out and they inspect the buildings and they assess the damage, because if there is any government program for compensation, and it depends on what kind of damage a particular building has suffered. So people go out now, if they are not experienced, typically they tend to overestimate. And something that a G3 damage someone may think is G4, or G2 someone may think is G3, but it's a question of experience. Alright, now just looking at some of the visuals, G1 damage, the very fine crack, hairline cracks in plaster, falling off of some plaster. Fine cracks often limited to plaster, one dimension, we already talked about that. The load carrying capacity of the structure is not reduced. Alright. Corrective actions that need to be taken. You don't have to vacate the building, because after a disaster, that's another situation where if the building is there's any risk involved, then people are asked to leave the building, to vacate the building. So whether we require to vacate or not. And typically the G1 damage requires cosmetic repairing, nothing more than that. Then you come to slightly wider crack, G2, okay, small cracks, 5 up to 5 millimeter or quarter inch. Cracks are two-dimensional, they have measurable length and width. Also in large areas, plaster falls off when this kind of damage takes place. Yeah, there's more damage to non-structural parts. If you remember, I had mentioned way back about damage after disasters, and in Jabalpur earthquake there was a parapet which had collapsed, which had killed a number of people. That particular earthquake, the total fatality was about 80. And just in one house there were people sleeping outside, enjoying the cool night, and the parapet fell on them. So parapet is a non-structural element. Chimneys are non-structural elements. There are a number of non-structural elements in the building. So in G2 damage, even if they collapse, it's still considered as G2 because it's non-structural. Yeah. Here's, you see the photograph here, where the parapet here has fallen off. Right? And the load wall, typically this pitch roofs have a load wall that holds the roof down. Also, they are kind of decorative. So these walls also easily fall off in earthquakes and even cyclones. High wind and then these walls collapse. Alright? And the load carrying capacity of the structure is not reduced appreciably. Okay. And you don't have to vacate the building. And typically the cracks are repaired by grouting and a little bit of splicing. We'll talk about that, what exactly grouting and splicing is. Then we come to G3 cracks. Cracks are slightly wider now, from 6 mm to 10 mm or quarter inch to half inch. And generally they are throughout the thickness of the wall, three-dimensional. They have length, width and depth. See, especially this length, width and depth, typically in when one starts to estimate the kind of cost in repairing. So, the depth and the width, they matter. Because whatever kind of, procedures you will carry out, that will have economic implications. Alright? Okay. Load carrying capacity of the structure is reduced appreciably because of the G3 damage. And you have to get the expert's advice to decide if one need to vacate or not. You can't just decide on your own. Alright? And the cracks have to be repaired with grouting and splicing. Then comes the G4 damage. Right? So, severe structural damage. Portions of wall in state of impending collapse, as I mentioned earlier. So, portions of wall can be tilting. Okay, you can see some part of the wall, a long wall like that, part of it is detached and it's tilting. And a little bit of shaking and it can go down. Bulging, thick walls. If you have stone walls which are about 18 inches thick, okay, if you remember I said that when you build a stone wall, stones have to be placed so that there is interlocking. Otherwise, the faces of the wall separate. When some shaking happens, one face may just start separating out. You can see a bulge, happening on the wall. And of course, with more shaking, then that one face may fall off. So bulging, the delamination is when one face falls off. And it doesn't happen only in stone walls, it also happens in brick walls. Brick walls which are like 13 inches and 18 inches thick. Because the old masonry buildings were multi-story, we had walls which were thicker than 9 inches. So if these walls are not made properly, the bonding is not done properly, then that delamination can take place. Alright? So this is the state of impending collapse. Or some chunks have already collapsed, like you see here. So this is all G4 damage. So of course the building is unsafe, can collapse further. And of course it has to be vacated. And first of all you do repair the minor damage, and then some of these things will have to be dismantled. Some portions which are tilting, which are in the state of impending collapse, will have to be removed and rebuilt. And of course G5 is where more than 50% building has collapsed, or the building is totally collapsed. So any of both the states can be considered as G5. Alright. So now, how to restore a damaged building? First of all, you document the damage. You have to mark the damage. So actually you will mark it even on the wall. So whatever damage that's there, whatever cracks that are there, you will highlight them, you will write down whatever grading there is. Okay. You categorize each damage. So whether it's G1 to G4, whatever category it is, you will categorize that. Then demarcate the extent of damage on the building in the documentation. So we'll have to prepare this document on paper. I'll show you the example. And then based on the damage, you decide the remedial action for each damage. Based on that, you decide how many materials are required, what is required. Procure the materials and you restore the damaged portion one by one. And once the damage repair and restoration is done,
then you apply the finish so that it matches with the rest of the wall. So it's forgotten. Now, how do you do the documentation? What you see here, ABCD, just a simple room, right, with 4 corners. So what you have to do is make a fold out. You understand? Fold out. Basically, we have just opened up the walls. Okay. So ABCD, A. Then you mark all the damage. Right? This is something that is marked on the wall, highlighted. Then show it here. Alright, so the cracks, with a grade 3, G3 cracks, G2 cracks. So all these cracks are marked. Some portion has delaminated, like this portion at the top. One face has fallen off, so you're calling it delamination. Right here in the corner, for example, in A, right here, because of this crack, portion of this wall is out of plumb. So something has to be done about that. Alright. Now, the non-structural items. Okay, then first is of course non-structural item. Now paint, plaster, all these things of course you do at the end. You don't do in the beginning. But there are certain things you may have to do, in the beginning. Flooring disturb also is all done, finished. Roofing tiles, plumbing damage. Sometimes electrification, some of these things may have to be done earlier because the ducts may be inside and you may have to open them up and things like that. Alright. But this is essentially the non-structural damage. Damage to parapet, as I mentioned, damage to chimneys. So these are taken care of at a convenient stage of the repairing. Alright. Now, you have G2 to G3 damage. It requires grouting with non-shrink grout and splicing across with ferrocement strap. The crack that you have has to be filled up. Okay. And when you fill it up, you need a grout which will not shrink. Because typical any kind of cement, ordinary cement grout, as it sets, is going to shrink. So, essentially splicing is something in addition to the grout, you put something across on the surface, okay, so that it prevents the cracks from opening up. Alright. So I'll come to the detail of that. There are different ways of splicing, so I'll come to that also. Then you have the G4, where you have bulge, delaminated walls, or things which are gone out of plumb. Requires removal of the damaged portion and reconstruction using same or stronger mortar. Alright? And this has to be done, the removal and reconstruction has to be done in such a way that it connects well with the things which are in place. Because you are removing only part of the wall, the rest of the wall is still standing. Alright, so it's important that they are connected properly. Otherwise, in a little bit of shaking in future, and they will separate. Alright? Walls out of plumb. Yeah. Okay. So an extensively damaged G4, G5. Yeah. Now, if the roof is intact, all right, if the roof is intact in a building and if the walls are badly damaged, it's possible that the structure can be salvaged. So let's see a case. I have some cases that we'll talk about. So this is, now we are showing the restoration here. Now, see here, for example, I've shown that this wall was out of plumb. Okay. But when you are fixing this portion of the wall, right here, rather this corner, if you are fixing and rebuilding this portion, then also the part of this also has to be rebuilt. Okay, so actually in this portion A, B, this portion actually first of all has to be removed in a step-like manner. Okay, masonry is, you can remove course by course, step by step, and then you build back this corner together, course by course, and you come back. So that's how it is rebuilt back. Alright? Okay. Even this portion also, of course, now this is in such a shape that rebuilding it back right here without any kind of dismantling, it's possible. Then these cracks, have to be grouted, and we see the splices which are put across. There are certain basic thumb rules about the splices. Okay, now a little bit about how it is done. Now, so if you have a G1 or G2 type of crack, you generally will come with a cutter, and you will cut it open a little bit, and then oftentimes the mason comes with a chisel and hammer, and they will make it kind of like a V groove, okay, so that one can put back the mortar in it, maybe some bit of grout in it, a little bit if it's possible, and then just seal it back. But mainly this is primarily a non-structural or just very light damage. So make a V notch along the crack, clean it with wire brush. Cleaning is very important, because anytime any kind of grout, any kind of mortar you're going to put back on it, if it's not clean, it's not going to stick. Okay, so clean with wire brush, even taking water and washing it properly so that all the dust is totally removed is very important, and it should be a little dry. And then you fill it up with a mortar, cure it, and finish it to match the surroundings. Alright. Then your G2, G3 level damage, grouting of through cracks for restoration of original strength. Now this is a thick brick wall we have in the school. So essentially, again, like I said, chisel and hammer, and you make a V notch and clean it with wire, wash it. Then you fix this grouting nipples. These are essentially small diameter flexible tubes, PVC tubes, about 75 millimeter or 3 inches long. And like every 6 to 8 inches or 150 mm to 200 mm, they are inserted in the wall. Okay, about half of them stuck in the wall. And then the crack is sealed on the outside with cement mortar, with rich cement mortar, with the nipples sticking out about 25 to 35 millimeter out. And then once that is done, basically what is important is that the crack is, after the nipples are put in, the crack is sealed on the face. Okay, so you only have this little tubing sticking out every so often, and then water is put into the crack for cleaning, right? Start from the topmost and come down. All right, and once that is done, then you come with the non-shrink grout, and there are different ways you can put it. It all depends on how sophisticated the setup is and where you are, what kind of infrastructure you are available. And in this, you start with the lowest nipple and then you move up slowly so that the crack gets filled. It's a little tricky operation, and it requires patience. So, and once the whole crack is filled, then we cut off the nipples and we seal all of them with cement plaster, and then you finish it. And of course, you do the cracking. All right. Then, of course, there are different ways. Now, also in the rural areas, we've used these kind of gravity feed drums. So you fill them up and you take them to some height, maybe 10 feet or something, and just under gravity pressure, the thing will do the job. I mean, essentially, you are improvising things, So, okay. There's another simple. Somebody came up with this pichkari, what we call, right? Which you play holy with. So a simple hand pump made from PVC pipe and a reducer, and that's it, So, and you fill up the slurry from the top and you do your work. So especially in the rural areas, improvisation is the name of the game, because you don't necessarily have the required infrastructure, power. Then we are coming to grade 3 cracks, and once again, the cracks have to be chiseled. You make the V notch and you do the cleaning and all that. But the most important after grouting is putting the splice. The question of what exactly is the splice. So let's the stitching of cracks. So there are different situations. We had situation when we could not get weld wire mesh, and this is going back in 2001 in Kutch earthquake. So we were using, just a simple, some kind of element made of reinforcing bars with chicken wire mesh on it, and these were anchored to walls with 6-inch nails. Alternatively, you can have weld wire mesh straps, which are 150 millimeter wide, and these are anchored with 4-inch galvanized iron nails, and these are put every so often, about say 300 millimeter apart, and they go on either side of the crack about 450 millimeter, so that they are anchored in a fairly solid wall, far away from the crack. Now, what is important that any kind of mesh which is placed on the wall, there should be a gap of about 10 millimeter between the wall surface and the mesh. And once it's there, because when it's plastered, what you see the plaster there, the plaster goes beyond the mesh. Alright, so between the mesh and the wall surface, you have the plaster, because that is what also creates a good bond with the wall. If the mesh is just nailed to this and you apply plaster, then the plaster becomes very superficial. It doesn't provide good bond, continuous bond with the wall, between the mesh and the wall. Alright, so that's an important thing. That gap has to be maintained between the mesh and the wall surface. And the plaster is applied in 2 coats of 12 millimeter thick. You see different, couple of cases of the splices at the corner, and like anything else, it has to be cured properly and do the finishing. Now there are situations when weld mesh is not available. There's something called C-clamp. Alright, so this is made of 8 mm or 10 mm deformed bar. Essentially, is a C-shaped bar, and here is the crack. So it goes about 300 to 450 millimeter on either side, and you have the leg, which is 6 inches, and it's just 2 holes are made, one here and one here, and it's put in, and the hole is ground. So this is like staples. We use staples to get the papers together. So this is an old way of doing things, and it has limited effectiveness, but if you don't have anything else, then even something like this also can be done. Alright, then you have different situation of damage. Now this is very typical. When you have a door and a window and the gap between that is not enough, then what you get, these kind of wrecking shear cracks, diagonal cracks. Alright? In a situation like this, this whole thing will have to be removed. So the wall will have to be propped up, and this portion, even somewhere here, the masonry will have to be removed, and then this part of the masonry will be built back. That's how the restoration is done. In the corner, you have a crack. What we do is just fill up the crack, ground the crack, and put several splices. Vertically, you can have several splices going across the crack on both faces of the wall. Okay, this is important. When you have a crack which is through and through, the splice has to be on both faces. Just applying the splice only on one face is not enough. Another interesting case, just think that in this building, that rear wall is intact, this wall is intact, this wall is intact. Why a damage like this would happen? Imagine. Why something like this would happen? It's like the wall is cut with a knife. Why would something like that happen? Can anyone guess? You have outside wall, you have inside wall. If they are not connected properly, if they are not built at the same time, then this happens. Basically, the outside wall is not held by the inside wall, and in case of earthquake, when you have forces perpendicular to it, this just falls off, and that's basically what has happened. that this wall here has just fallen out because this wall and this wall were not holding that wall. So to put this back in the original state or better state, actually this particular wall would have to be dismantled in a step-like manner. This wall here also would have to be dismantled. See, this is already in a step-like situation. So then you start building this along with this triangular portion. See, basically, to build back this wall which has fallen off, this particular wall will have to be dismantled in a step-like manner. This particular wall also will have to be dismantled in a step-like manner. This wall here is already broken like that, so it's fine. So now you take course by course as you come up. You will also be building part of this wall, part of this wall. So all main wall here and the two other walls will be built together, part of it, so that proper bond takes place. Alright. Another case here where the wall is completely gone, but the roof is intact. So something like this again can be, just prop up the roof properly, build back the roof, but here again, you will have to dismantle parts of this and parts of this to have proper connection with the rest of the wall. Okay. There are no shortcuts to this. This particular case, see, I mentioned earlier about the gables being very weak. These gables, because they are unsupported, when there is an earthquake force in this direction, or like it's shown in the arrow, the gable walls vibrate back and forth, and they're not properly restrained, this kind of crack happens. So this crack can be grouted, you can have some splices put in, okay. So that much can be done, and then of course you need to properly anchor the roof to the wall and do few other things so that damage doesn't occur in future like this. Okay, if you have reinforced concrete or wooden elements which are damaged, you will have to do maybe some kind of splicing, some kind of grouting. There's fine cracks in reinforced concrete elements. They can be grouted with epoxy. It's pretty easy, provided you have proper equipment, and it really works very well. It's very effective. All right. So, I think that basically is now a situation like this. This is a classic situation. Typically, people tend to abandon this building. Okay. Most engineers will say, forget it, demolish it. Okay. But no, you don't have to do that. And there is a way to restore it back to its original situation. Let's look at this. This is a situation. Alright, so you need to support first of all the undamaged slab. Then you mark the concrete. You will have to remove the concrete. Alright. Concrete is removed. And the bars are exposed. We straighten up the bars. And we also show extra concrete to be removed. This is basically to have that development length. Alright. Then you put shuttering underneath. You have removed that additional concrete. Okay. Then you put dowels. Alright. So you had basically the bars were damaged here along this line. Now we have gone beyond that, which is equivalent to the development length for this bar. So this is where the bar was bent. We have gone this far back, and now we are putting dowels to straighten out the bar. So what you get is this, right? You have dowels connecting the good portion of the bars, over the place where the bar was damaged. Right? Once this is done, do the concreting, do the curing, and you are done. And of course, the wall underneath has to be rebuilt before anything else, which I forgot to mention. Right? So that is right at the earliest stage itself, after removal of the concrete, if this wall is built back, that's the only way that you can put the shuttering here, alright? So this is commonly seen that buildings which are severely damaged, people won't get rid of them, and engineers are more than happy to do that. Okay, so, and we saw some actually in Kashmir after 2005 earthquake. It was the most impressive the way people had done, the restoration of the damage. Now, like this is ground plus one, yeah. So this is broken. This is, see the kind of props they have put in, alright? And they'll put back this part, then they'll restore the roof. This particular building, this guy, the owner of that was working with road and building department, but not an engineer, okay? So, and I think he had good construction experience. So this particular wall was badly damaged. So see, he has removed this wall in a step-like manner and put it back. So it was really amazing. So essentially, as you see in the sequence here, okay, so you have the damage, so you prop up the roof properly, and then you remove portion of this wall in a step-like manner, so that you start again building back the wall, and then you finish rebuilding it, and then put back the roof. So it's done. Yeah, here are some more cases. Now imagine this particular case. This reinforced concrete roof, there is a lintel right here. So they have put these supports right here, and then they will start rebuilding the wall. Some more cases, ground plus one cases. Now, this is a situation where you have a bulged wall, correct? The bulge is right in the middle of the wall, which means you remove not only the bulge portion, but portion above it and on both sides in a step-like manner as it's shown in the picture. Alright. Now you are ready, wall ready to be rebuilt with the roof propped up, and you start building back the wall. Okay. So these require some patience and systematic planning, but you don't require any special equipment to do these things. Alright. Okay, here's one more example. Basically, you have a wooden structure on the top with random rubble masonry in mud water portion that's pretty badly damaged. So, they have propped it up nicely. You propped up the upper roof and then propped up the upper story from underneath. And you can see it's done in step manner, and then they'll put back the wall. Alright, just a few more examples. And of course, these are waiting to be restored. I think because there were so many houses damaged that so many of them were propped up, and as the contractors and the masons got time, they would take care of it. Yeah. Then another thing, you have a roof which is damaged. So again, you dismantle the roof, put back the walls again, and put back the roof. Alright, restorable buildings. Just summarizing, many buildings at first glance, they appear unsalvageable. They look like it's finished. Alright. Fear psychosis in people, and even some engineers make them opt for demolition. In Latur, back in 1993, something like 35,000 houses were destroyed in a very small area. The fear was intense, okay? And over a very large area, 220,000 houses were damaged. But during the next 1 year after the earthquake, engineers were, like Rupal has said, that engineers will come and say, "Patthar hai nikal do, mitti hai nikal do." So that fear, and people felt that their houses had no future and they were not safe. So we believe that more than 50,000 houses were dismantled out of fear. And there were these contractors coming from outside, and they will say कि आपको 5,000 रुपया देंगे, हम आपको पूरा घर निकाल के दे देंगे, They would take away the stone, and they took away the timber. Each house had so much of timber. Solapur was the nearest big city. So trucks used to come from Solapur, they would be loaded back with timber. And the stones were just, thrown right there. So out of fear and out of wrong information, people lost so much. But Kashmir, we saw that. I think because maybe, they are so far away, so remote, and I think they are more industrious and more creative. So, fear psychosis works. If planned properly, many of these buildings can be restored, thus saving huge unnecessary expense and hardship. And see, once something is dismantled, to put it back is going to be a year, because you will never have enough money. Most of the people would have money. Alright? Damaged portions can be rebuilt, but all undamaged walls and roof need not be dismantled. Yeah, all the buildings, there are some more examples of buildings which can be restored and retrofitted. We'll talk about retrofitting next time. Here are the buildings with a little bit of damage. G2, G3 damage. You can see the cracks here. These are like grade 2 and grade 3. This is a little more. Maybe this portion may have to be removed. The roof may have to be supported, and some part of the wall may have to be removed and rebuilt. Again, small. The problem is either people don't do anything, the masons will just come and fill up the cracks, and then it's out of sight, out of mind. Okay, you fill up the cracks, you put whitewash on it, and you forget about it until the next earthquake. In Kutch, there was an earthquake in 1956, a major earthquake. And at that time, there was really no understanding, there were no efforts, government didn't take any effort. This was way back immediately after the independence. So things which were completely destroyed or rebuilt, but the rest of it was just, put back somehow and whitewashed. So those buildings which were damaged then and just restored in some way, they suffered enormous damage in 2001 earthquake. Anyway, these are just examples of light damage. Now, these are examples of heavier damage, but all these can be, put back. Now, this particular case at the bottom, the ground story is fine. It's only the upper story is very badly damaged. That can be dismantled and can be put back using most of the same material also. So, attention building owners. If building is damaged, in hurry, do not dismantle anything out of fear. These are the messages which need to be conveyed in case of a disaster. Be in a hurry. Don't be in a hurry to repair and dismantle the damaged house, partly or fully. Take advice from untrained and unknown people. Wait for government directive. Okay, very important. All right. Don't follow blindly what others are doing. In 99 Chamoli earthquake, it was very interesting. See, in most, if properly built houses, the damage will be always maximum on the bottom story because the inertia forces accumulate in the bottom. But in a poorly built house, because of shaking back and forth, whipping action is the upper story that gets damaged more. And in Uttarakhand in 1999, a lot of the villages, the ground story was intact, the upper story had cracks in the corners. Every house you would see will have cracks in the corner. So somebody started dismantling the upper story. And pretty much, people started following that. And, in the mountains, you don't have flat land. And if you lose a story, where are you going to go? Are you going to live in tin sheds? So wrong information, wrong trend. So do not remove the upper story just because it is more, it was unbelievable. So you saw these houses, with the tin from the upper story put on the lower story. So big loss to people. Those corners could have been just dismantled and repaired and everything would have been all right. Don't add reinforced concrete and steel columns and troughs in buildings to bring safety. We saw that after Kutch earthquake in Ahmedabad. In the ground story, all these so-called experts came and, they cheated people and do this. Again, the wrong thing to do. The building, do not make mistakes in rebuilding. Do not make mistakes in rebuilding that were responsible for damage to begin with. Whatever damage that took place in the building, it was because of some mistakes. You rebuild, don't make those mistakes. Do not use scarce money for plastering and flooring. Again, this is something the government gives you some money, whatever money. People will use it for flooring. In their existing house, they will do some plastering and then they will do, that using money on the flooring doesn't bring strength to the building. Alright? Do not build anything that is not disaster resistant. Select options and materials that you can't afford. Don't select such things. And do not neglect the disaster resisting features. We have talked about the bands and the reinforcement and the encasement of openings and things like that. Things to remember: assess need for repair of damage. Okay, anyway. Understand the situation and evolve solutions. You don't have textbooks situation. Alright, you have to look at the building, you have to understand what the problem is, and you have to evolve the solution. Always look at the structure from saving it for demolition and objectively decide the course of action. If it's in your mind, you go with this mind of demolition, then you will not see any solution. But you decide that, hey, I'm not going to demolish, then you will find solution. Be ready for the real life situation rather than a hypothetical textbook situation. Demand adherence to the right procedure to ensure proper performance. And exercise caution not to damage or weaken the structure. A lot of times people will bring crowbar and they will do something. You need to use skill and trick rather than brute strength. Alright? So, okay. And finally, if you are in an area of moderate or high seismic or cyclone risk, restoration alone is not enough. The future earthquakes and cyclones can cause severe damage or collapse. So, you need to retrofit your building, not just restore it. Okay?